Hello everyone and welcome back to our Spring Boot tutorial series. In today's video, we're tackling a common issue that many developers face, circular dependencies. If you've ever encountered a bean currently in creation exception, you know what I'm talking about. Stick around as we dive into what circular dependencies are, why they happen, and how to resolve them effectively in Spring Boot. What are circular dependencies? A circular dependency occurs when two or more components depend on each other to function. This situation can arise either directly or indirectly, creating a loop that frameworks like Spring cannot resolve during dependency injection. For example, consider two classes, Employee Service and Department Service. Employee Service requires Department Service to perform its functions and vice versa. When Spring attempts to initialize these beans, it finds itself in a loop, unable to proceed because each service depends on the other being initialized first. Circular dependencies are more than just a theoretical problem, they can cause real issues in your application, leading to crashes at runtime. Spring Boot's dependency injection mechanism relies on a clear path of dependencies, each with a defined start and endpoint. However, when a circular path exists, Spring faces a dilemma: it can't decide which bean to initialize first. This indecision often results in errors and prevents the application from starting successfully. Let's look at a practical example to understand this better. When Spring Boot starts up and tries to create an instance of Employee Service, it recognizes that Employee Service requires an instance of Department Service to function. It then attempts to instantiate Department Service, but here's the catch: Department Service also needs Employee Service to be functional. This interdependency creates a cycle: Employee Service needs Department Service, which in turn needs Employee Service. This looping dependency results in what's known as a bean creation exception. Spring cannot resolve this issue on its own using constructor injection because it becomes trapped in an endless loop trying to instantiate the beans. Let's talk about some common pitfalls in application design, especially when it comes to circular dependencies. First off, circular dependencies often signal a flaw in your application structure. This happens when two classes are too dependent on each other, which is a sign of excessive coupling. Next, there's the misuse of Spring annotations. Using annotations like at AutoWired, at component, and at service incorrectly can also lead to circular dependencies. It's crucial to understand how these annotations work and to use them properly to avoid such issues. Let's discuss some effective strategies to combat circular dependencies in your project. First, let's break down some strategies to rethink our design and make our applications more robust. First up, decoupling classes. It's essential to reduce the interdependencies between our classes to prevent these endless loops. How can we do this? Well, we might consider introducing new classes or interfaces specifically designed to break these cycles. It's all about simplifying the interactions between components. Now, let's talk about design patterns. Using patterns like the facade, mediator, or observer can significantly help manage complex interactions within your system. These patterns are not just theoretical, they provide practical frameworks that you can apply to solve specific design issues effectively. Moving on to Spring-specific solutions, which many of you might find helpful. One common issue is using constructor injection for dependent beans, which Spring struggles with in circular paths. A better approach? Setter injection. These methods allow Spring to initialize the bean instances first, setting the dependencies afterward, which can often resolve those tricky circular dependencies. Another powerful tool is the @lazy annotation. When used with AutoWired, it defers the initialization of a bean until it's actually needed. This lazy loading can be a game changer in managing your dependencies more efficiently. For those who like to have more control, implementing application context-aware and programmatically setting dependencies is a great approach. It's a bit more advanced but gives you direct control over the injection process. Don't overlook the @postConstruct annotation. It's incredibly useful for doing any initialization work after all dependencies are injected. While it doesn't solve circular dependencies directly, it helps manage initialization issues, ensuring everything is set up correctly. Lastly, consider refactoring to a service locator pattern. This involves using a central registry for accessing services and dependencies, allowing you to avoid constructor injection and manually control how dependencies are resolved. In our Spring Boot project, employee service and employee service impl are unused files. Let's delete these files. For our circular dependency demonstration, let's create a new interface named Department Service. Define two methods named getDepartmentName by employee ID and getEmployeesInDepartment. Next, create another interface named Employee Service. And define a method named getEmployeeDetails in Employee Service. Next, provide implementations for both Employee Service and Department Service. Create a new class file named Employee Service impl which provides the implementation of Employee Service. Implement all methods present in the Employee Service interface in your Employee Service impl class. Annotate this class with the @service annotation to designate it as a service layer component. This annotation is part of the Spring framework and it tells the Spring container to treat this class as a service. Define a Department Service variable inside the Employee Service impl class. Add a constructor to the Employee Service impl class for injecting the Department Service dependency. If you're unfamiliar with what a constructor is or how constructor-based dependency injection works, I recommend watching this video first. Let's now implement the getEmployeeDetails method. From this method, we will return the employee ID and the department. Retrieve the department by calling the getDepartmentByEmployeeID method from the Department Service. Next, let's provide an implementation for Department Service. Create a new class named Department Service impl. After creating the class, we'll implement Department Service and override all the methods defined in the interface to ensure our Department Service impl class provides specific functionalities for each method. Now, let's annotate our Department Service impl class with the @service annotation. This tells Spring that this class is a service layer component, which is crucial for the dependency injection framework to manage it as a bean. Next, let's define an employee service variable inside the Department Service impl class. Recall that in the Employee Service impl class, we have already declared a Department Service variable. This setup creates a circular dependency because employee service depends on department service and vice versa. This is a key example of what we're addressing in today's tutorial. Add constructors to our classes for dependency injection. Next, let's implement both methods in our services and return hard-coded values. Finally, let's start our Spring Boot application. Here, we can see that our Spring Boot application has failed to start. As seen in the log, Spring Boot suggests updating your application to break the cycle dependency. Just scroll above. Here, you can see that Spring shows a circular dependency between department service impl and employee service impl. Using the @lazy annotation is one approach to resolving circular dependencies. This annotation instructs Spring to delay bean instantiation until it's needed, helping to mitigate circular dependency issues. Add the @lazy annotation just before the department service variable in the constructor of the employee service impl class. Open the department service impl class and add the @lazy annotation just before the employee service variable in the constructor. Placing the @lazy annotation just before a variable in Spring indicates that the bean associated with that variable should be lazily initialized. This means that the bean will only be created and initialized when it is first requested by another part of the application, rather than being instantiated eagerly when the application context is loaded. Now, let's start the application server. We can observe that our Spring Boot application started successfully this time. By marking the dependencies with @lazy, Spring doesn't instantiate the dependent bean immediately when the primary bean is created. Instead, it creates a proxy to act in place of the actual bean, and the actual bean instance is only created when it is first accessed. This approach resolves the circular dependency issue as the instantiation is deferred until it's needed, avoiding conflicts during the initial creation phase. Next, let's stop the application to make further changes. After that, we'll create a REST controller to test whether dependency injection with @lazy is working properly. Create a class named Circular Dependency Controller. Annotate the Circular Dependency Controller class with @REST controller. Let's define a variable employee service inside our Circular Dependency Controller class. To inject the employee service dependency, we'll use constructor injection, ensuring proper dependency management in our Spring Boot application. Next, let's define a method named getEmployeeDetail in our Circular Dependency Controller class. Call the getEmployeeDetail method from employee service, passing a hard-coded employee ID 23 as an argument. Annotate this method with @getMapping and specify the path as /circular/dependency/employee/details. Let's start our Spring Boot application now. Great! Our Spring Boot application has started on port 8090. Next, let's open a browser to see how our application behaves with lazy initialization and dependency injection in action. Type localhost 8090/circular/dependency/employee/details in address bar and press enter. As we can see, we received the expected response. This indicates that all components are working properly, including lazy initialization and dependency injection. Currently, we resolved the circular dependency using lazy initialization. Now, let's explore what happens when we try to manage this dependency through setter injection. To inject the dependency using setter injection, let's first comment out the constructor in the employee service impl and department service impl class. Next, let's add a setter method for the department service variable in the employee service impl class. Don't forget to annotate the setter method with it autowired to enable Spring to inject the dependency. Open the department service impl class and define a setter method for the employee service variable. Annotate this setter method with it autowired. Let's start our Spring Boot application now. Oops! Our Spring Boot application failed due to a circular dependency. In the logs, Spring suggests resolving this issue by adding spring.main.allowCircularReference equals true in either the application.yml or application.properties file. Let's open our application.properties or application.yml file and add spring.main.allowCircularReference equals true. This configuration tells Spring to allow circular references, which can help resolve the issue. Let's go ahead and make this change in our configuration file. Let's start our Spring Boot application. As we see this time, our application successfully started. When you set spring.main.allowCircularReference equals true in your application.properties or application.yml file, you're instructing Spring Boot to allow circular dependencies during bean initialization. By default, Spring Boot does not allow circular dependencies because they can lead to initialization issues and potential runtime errors. Let's open our web browser now and reload the page to see the changes. As we can see, the application once again returns the expected response. This confirms that setter injection also properly injects circular dependencies. To prevent these issues, it's crucial to design your application with good software architecture principles. Utilize interface-based programming and divide responsibilities wisely among different components. This not only makes your application cleaner but also easier to manage and scale. To recap, today we explored what circular dependencies are, how they can crash your application, and various ways to resolve them in Spring Boot. Remember, understanding and resolving such issues is key to building robust and efficient applications. Thank you for watching today's tutorial on circular dependencies in Spring Boot. If you found this video helpful, please give us a thumbs up and subscribe for more tips and tutorials. Don't forget to hit the bell icon to get notified about our latest videos. Drop your questions or topics you'd like covered in the comments below. Happy coding!